Hi, and welcome to another Dech Academy video. So I got question 26 here, and it says an object is 6 meters away from the base of a mast. The angle of depression of the object from the top of the mast is 50 degrees. Find, correct to 2 decimal places, the height of the mast. So we want to find the height of a mast. So the situation described is as follows. There is a mast. So before I draw the mast, I'll draw a ground level or a horizontal ground level. So we have a mast which you'll take to be vertically erect. So I'm going to depict it with this line. And you're told that an object is 6 meters away from the base of the mast. So we're working at the level of the base of the mast, which is the ground level. You have an object. So this is the mast. This is the base of the mast, and we have an object 6 meters away. So an object is located here. So you can call this distance between the base of the mast and the position of the object. So I can call that O, 6 meters. You're told that the angle of depression of the object from the top of the mast 50 degrees. That really means that this angle here is 50 degrees. That's the angle of depression, where this dotted line here is parallel to this line. So like I said earlier, this mast is perpendicular to the ground level. If I extend this line with the dotted line, that means this angle here is 90 degrees. That means this angle here corresponds with this whole angle here, or this angle rather, which simply means that this whole angle is 90 degrees. And if this part is 50, this must be 40 degrees for the whole angle here to be 90 degrees. So we now know this angle is 40 degrees. And the question says find correct to 2 decimal places the height of the mast. So we want to know h, the distance from the base of the mast to its top. So what you have is a right angle triangle. You know that this angle is 40 degrees. You know this angle is 90. And because all angles in the triangle add up to 180 degrees, this is 50 degrees. So we have a triangle where we know all the angles and we know the value of one side. We don't know the length of the height. So you can use SOHCAHTOA here. And I'm going to use, well, if I focus on the 40 degree angle, the tan of 40 degrees is the opposite length of the opposite side, which is 6, divided by the length over the adjacent side, which is h, simply meaning that h is 6 divided by tan 40 degrees, which from your calculator to 2 decimal places is 7.15 meters. So that's a decimal place. And that's pretty much it. So one thing to clarify is the meaning of a mast. So you must of course come across flagpoles and flags, and there's this term used where flags are flown at half mast. So think of a mast as the flagpole. So imagine you have a ground and you have a mast. So think of it as a flagpole. Erect, vertically erect. They're usually always vertically erect, and that's the situation you have. And you're told that there's an object. So this is the mast. Think of this as the mast. This is a mast. And you're told an object is 6 meters away. So let's put the object here. And let's call this distance 6 meters. And you're now told the angle of depression of the object from the top of the mast. So let's go to the top of the mast. See the angle of depression of the object from the top of the mast 50 degrees. That means that we draw this dotted line here. The angle of depression is always this angle. From the top of the mast is always this angle. So, the question then says find correct to 2 decimal places the height of the mast. So like I said, the mast is always erect, vertically erect. It's always at right angles to the ground. So you think of this line here, this horizontal line here as the ground. This vertical line is representative of the mast, which is at right angles. We have the length of one side, 6 meters. and you have an angle here 50 degrees, and this angle here is always, I mean, if you put it this way, this dotted line, I've drawn it to be perpendicular. This dotted line here is perpendicular to this mast, and this whole angle here is 90 degrees, which means that this angle and this angle must add up to 90 degrees, and this angle must be 40 degrees, because 40 plus 50 is 90. So basically what we have is a right angle triangle. So you're going to be using things like Pythagoras or sines, cosines, and all that to solve this problem. So you have the heights, unknown heights you're trying to find. You have this angle is 40 degrees, you have the angle is 90 degrees, which means that this angle is 50 degrees, because all the angles in a triangle must add up to 180. So this angle plus this angle plus this angle must be 180, and we knew that this was 40, we knew that this was 90. 90 plus 40 is 130. That means this angle must be 50. We've been told that this length is 6 meters, and if asked to find the height. So how would you proceed? Well, the easiest way is just to pick one of the angles and use either sine, cosine, or tangent. So just have SOHCAHTOA by your side, and let's say we pick this angle 50 degrees. Now this side is opposite. It's the opposite side, and so we know the opposite side is 50 degrees. Let me put this way. This side is the hypotenuse, because it's right opposite the right angle. We don't know the length of the hypotenuse. Okay, that means this side must be the adjacent side. We know the length of the adjacent side as 6 meters, so I'm going to mark adjacent. So we want to find the height, which is the opposite, and we know the adjacent, and we know the angle. So let's start with this angle. Let's start with this angle 50 degrees, and using this angle, the length of this side and the length of this side, let's try and find h. So this angle here is 50 degrees, and the opposite side to this angle is h. The adjacent side is 6 meters, because this long side opposite to the right angle is the hypotenuse. So if you use this angle, the adjacent side and the opposite side, we have a situation involving the opposite and the adjacent side of a certain angle, and that situation will require us to use the tangent, TOA, because as you can see here, we're using the opposite and adjacent. So if I take the tan of 50 degrees, which I know, which you can do from a calculator, from this triangle setup, you know that tan 50 must be the length of the opposite side, h, divided by the length of the adjacent side, 6. From your calculator, tan 50 is something, but if we make h the subject of a formula, so if you multiply both sides by 6, you get 6 times tan 50 degrees equals h, which means h is 6 times tan 50 degrees. And from your calculator, you get that h is 6 times tan 50, which is to 2 decimal places. I mean, okay, so from your calculator, you get something really long, but to 2 decimal places, your result will be 7.15 meters. Let me just even work it out on a calculator. So you went to your calculator, making sure your calculator is in degrees, not radians mode. 6 times tan 50 will give you 7.1. This actually have given you 7.1505, which the 2 decimal places can be simplified to 7.15. And there's nothing to round up because the term after is 0. So there you go, 7.15.